Hey everybody, here's a video that could help you on your homework tonight. This is actually an assignment we're turning in, but some students took it home to finish. I'm going to give you some tips that can help you. I'm going to go fast, but you can pause this video or go back and watch it as many times as you need to. The easy problems are up at the top, just asking for you to write the ratio in simplest form, and then as a decimal, and then explain its meaning. But there's a couple of tricky ones down here. And so I'm going to show you a couple of those, and then you can apply the steps and the procedures to all of the ones on the paper. First of all, let's look at number 8 for a second. In the jazz band at Wyatt School, there are 15 trumpets and 9 trombones. Determine the ratio of trombones to trumpets. Be careful. Just because they gave us the trumpets first and then the trombones doesn't mean that the ratio is trumpets to trombones. In fact, it's the opposite of that. Read carefully. Determine the ratio of trombones to trumpets. Okay? So we are looking for trombones to trumpets, meaning we don't want 15 over 9. We want the 9 trombones over the 15 trumpets. And there's a few ways we can write a ratio. We can write that as a fraction. We can write that as 9 to 15 or 9 to 15. This way is a few different ways we can write the ratio. We've been writing them as fractions because when the fraction needs to be simplified, or when the ratio needs to be simplified, we've got to look at it like a fraction. So most of the students are writing them this way. So to finish this properly, we would simplify the fraction if possible and then write it as a decimal and explain its meaning. All right, what I'm going to do is solve number 11 here, and then you can apply that towards all the other ones on the page and practice as much as needed. Mr. Riley allowed a class of 6th graders to choose an activity for their gym class. What is the ratio of students playing volleyball to the total number of students? Write the ratio as a fraction in simplest form and as a decimal, then explain its meaning. So, what we want to do is those 3 things. First, let's write it as a fraction in simplest form, but let's know what we want. Okay, I had students write down things to help them. So I'm going to use V for volleyball. So we are going from volleyball to the total number of students. So I may just write down something to help me know what I need. All right, so I want V for volleyball. That is 12 students. So my ratio is going to be 12 to whatever the total is. So I'm going to come over and take a look. 12 plus 21 plus 3. That's going to give me a total of 36. So my ratio is 12 to 36, or as a fraction like I've got it here. Now I need to simplify it if I can. Of course I can simplify this fraction because both numbers are even numbers. So at the very least we can divide by 2 because they're even numbers. Some students are going to notice that 12 and 36 have a common factor of 12, and that we could just divide by 12 and be done with it in one step. Let's assume a student doesn't know those factors, and if we could only divide by 2, could we still get down to simplest form? The answer is yes. Here's how we would do that. Dividing by 2 is just like cutting something in half. So half of 12 is 6, and half of 36 is 18. We still have even numbers, so we could divide by 2 again. Half of 6 is 3, and half of 18 is 9. We don't have even numbers anymore, but that does not mean that we're finished simplifying. There could be a common factor between 3 and 9, and there is. They share the common factor of 3. So this time, both of these we were dividing by 2, here and again here. Now we would be dividing by the common factor of 3. So if we divided both of these by 3, 3 divided by 3 is 1, and 9 divided by 3 is 3. So our ratio in simplest form is 1 to 3. So for every 1 volleyball player, there are 3 total students that chose the other gym class activities. And so we would need to now write this as a decimal. Most of the students in our class know that 1/3 is equal to 0.333 repeating. Okay. And if we rounded that to the nearest hundredths place, which is what we're doing today, that would just be 0.33. So we would have our ratio in simplest form. 0.33 would be our decimal. All we would need to do now is write the explanation. Let's assume the student doesn't know that 1/3 is equal to 0.333. They've got to do some division to figure that out. And so we've worked on this at the beginning of the year. How do we change a fraction to a decimal? We divide it, and we've got to make sure we're dividing it properly. When we do this and we divide this, we say the top dog gets the house. In the house, we're referring to the division symbol. So the top dog on top is the number 1, so it gets the house. Students are still mixing these numbers up very often. If you're watching your student work on this tonight, make sure they're putting the numbers in the correct places when they go to divide to make this the proper decimal. We follow the steps of division now. Many of you will go ahead and tell your child that 3 can't go into 1, so let's put a decimal point here and make this 10. And yes, you can start that way. Most of my students don't see it like that. They see it as, let's follow every step of the division. So can 3 go into 1? The answer is no. So that's 0 times. 0 times 3 is 0. Subtract and bring down, but there is nothing to bring down. So here is the point for them when they realize when there's nothing to bring down, it's time for a decimal point. So we copy that immediately to the answer bar so that we know where it goes and we have the right number when we're done. Now we can bring down as many zeros as we need to solve this. So when we bring that down, now we're dividing 10 by 3. So 3 goes into 10 3 times. 3 times 3 is 9. Subtract and bring down again. So we're going to continue with our zeros, bringing them down as many as we need. We need to get to the hundredths place. So we're going to keep going. 3 goes into 10. 3 times 3 times 3 is 9. And you see where we're going to end up. No matter how long we do this, we're going to keep bringing down zeros, and we're going to keep getting 10 minus 9. No matter how far we do this, okay? Not every one is going to be a repeating decimal, so be careful. So we've been taught today to round to the nearest hundredths place for our ratios. This 3 right here, the rule is we're going to use it to round to the nearest hundredth place. If this digit is 5 or more, then we say go up a floor, meaning this 3 will go up to a 4. If this digit is 4 or less, we're going to let this digit rest. This 3 is 4 or less, so we're going to stop with 0.33, okay? So now you ask yourself why. Why would we stop at the hundredths place? The reason why we would stop at the hundredths place is because in a couple of days when we start changing these to percents, we can use the hundredths place really easy to make this, to talk about how this is equal to 33 over 100, which is equal to 33%. So that's why we're going to the hundredths place, but we'll use that the next couple of days. So have your student not stop at the hundredths place. They need to go to the thousandths place so that they can round to the hundredths place. So we've checked and our decimal is correct with our division. Now all we need to do is explain the meaning of the ratio. There's a few ways that we could do this. This is a special one because it has a 1 in the numerator, so there's a couple of ways that we could explain this. I'm having them write sentences to explain this. I'm going to use a little note here because I'm going to run out of room. But there's a few ways we could explain this. We could say this. There is one student playing volleyball to every 3 total students. That's the basic way that we could write a ratio. And we could do that for any ratio. If it was 2/7, we could say there are 2 students playing volleyball for every 7 total students. But because this has a 1 in the numerator, there's a multiplication relationship between it and the denominator that would allow us to explain it in a couple of other ways. I'm not going to write the sentence, but I could write this a couple of other ways. I could say there are 3 times as many students as there are students who are playing volleyball, because 1 times 3 is 3. I could say there are 1/3 as many students playing volleyball as compared to the total number of students. So we want them to see that relationship of whatever the ratio is. I'm going to use a different ratio that works better than this, but if I'm still talking about 1/3, but I'm talking about cars to trucks, we want them to be able to say there are 3 times as many trucks as cars, because 1 times 3 is 3. We want them to be able to say that there is 1/3 as many cars as there are trucks. And one more time, if we have a different type of fraction where we don't have a 1 in the numerator, we can't do that. You can't say that there are 7 times as many cars as trucks, because 2 times 7 is 14 and not 7. You can't say there are 2/7 as many cars as trucks. It doesn't work that way. But when you've got this 1 in the numerator, there are some special ways that you can show the relationships between the numbers in the ratio. So when students explain the meaning, they should really have almost everything is going to sound like this one. There is one student playing volleyball to every 3 total students, because a lot of the ratios are going to be like these, where there's not a 1 in the numerator. So they need to explain them as best they can, and they can apply these rules to all of the other questions on the page. I hope this helps, and hope we can get to a point where we have mastered this as we continue working on ratios and rates over the next few days. Thanks for watching.